Okay, now my friends, exercise 1.3, question 4, express 0.9999 up to infinite in the form P upon Q. And while you read the answer, you will be surprised why this type of answer to be get. Okay, we will discuss it. Now, as you know that, let x is equal to 0.9999 and up to infinite. Since one number is getting repeated, so we have to multiply it by 10. So 10x is equal to 9.999 like this. Now 10x minus x will be 9.999 minus 0.999, because the value of 10x is 9.9999 and value of x is 0.999. so this is the stereotype process. Okay, now 10x minus x is equal to 9x will be 9.999 minus 0.999, that is 9. So x is equal to 9 upon 9 and x is equal to 1. Wow, aren't you surprised with this answer? 0.99999. So if you go to 0.99999 and up to infinite, so the exactly next to that, if we think, it is 1. Okay, now why this answer? Because the rule is, so if you want to convert this type of rational number into decimal expansion, the rule is that if 0.p bar means 0.p, where p is an integer, would be p upon 9. Okay, for example, 0.2 bar means 0.2222 will be give you 2 upon 9. 0.4 bar will be 4 upon 9. Okay, 0.7 bar will give you 7 upon 9. Okay, and the second one is 0.pq bar, means if you get two digits getting repeated in the repeating block, then the direct answer for that is pq divided by 99. Okay, now let us take an example for it, that is 0.13 will give you 13 divided by 99. If it is 0.47 will give you 47 divided by 99. If it is 22 divided by 22 bar, rather 0.22 bar, it's a 22 divided by 99, that is 2 upon 9. So look at the pattern of the question. So the before decimal point there must be a 0 and two digits are getting recurring means repeating. So repeating block, there are two digits. So this is what the rule says. Okay, very good. Okay, my friend, question number 5. What can be the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. My friends, many a time if we divide the numbers, we get so many numbers in the quotient. So we want to know that after how many digits the repeating block will be completed and the next block will start. So how many digits will be there in the repeating block if the number is non-terminating and recurring. Okay, so there is a rule and we will learn this. See, if 1 is divided by 17, look at it, 1 divided by 17. So with the start, we started with 1 as a remainder. So look at it. This is the performance. This is the long division to check our answer. Okay, so this is the long division. We just want to learn the rule only. Okay, we moved to 1. So we started with 1, and when you get the remainder is equal to 1, you have to stop. And now henceforward you will get the repeating block. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. If you go further, you will get the same block again. 0, 5, 8, 2, 3. So this block of 16 digits will get repeated. So when we started with 1 and we moved to 1 as a remainder, so henceforward we'll get the same block as a repeating digits. So what the rule says about, see, in the decimal expansion of the number 1 upon m, see, the numerator must be 1 and the denominator can be any number. If this is the number, that rational number, we have to find a repeating block for it. There can maximum be m minus 1 digit. See, here the divisor is 17, so we get 17 minus 1 is equal to 16 digits. There can be 16 digits in the repeating block of digits. This is the repeating block of digits. So my friend, it's a maximum number, It is not always that there should be 16 digits, or if it is not always that, it is a maximum digit there can be, not more than that. It can be less than that. So this is the rule. Okay, very good. Now question number 6 of this exercise 1.3. My friend, here we have to learn some rules. These questions make sense of some rules of decimal expansion of the given rational numbers. We know that decimal expansion of rational number can be terminating or non-terminating. But without actually performing the long division, just looking at the rational number in the P upon Q form, will you be able to say that the decimal expansion of the given rational number will be terminating or non-terminating? Yes, you have to learn here using this question. You will be able to say that this particular rational number in the form P upon Q will have terminating decimal expansion, and this particular number in the form P upon Q will have a non-terminating decimal expansion. Okay, so look several examples of rational numbers in the form P upon Q. So we have selected some examples where P and Q are integers with no common factors. So we have to choose such a rational number that numerator and denominator must be integers, and moreover they must not have a common factor other than 1. Means both of them must be co-primes. Here 1 and 2 have no common factor other than 1. 3 and 8 have no common factor other than 1. 2 and 5 have no common factor other than 1, though this one is decided that they have common factors other than 1. So there can be example to learn. There can be some more example to learn. I want to teach you something. Okay, so these are the three examples. They have no common factors other than 1. Now look at it. And the decimal, what is it? 1 by 2 is equal to 0.5. 3 by 8 is equal to 0.375. I am not performing the division. You can confirming. You can check it. by the long division. Okay, I just want to teach you one rule. Now 2 by 5 is equal to 0.4, 16 upon 100 is 0.16, and 18 divided by 500 is 0.031. So I will keep this to make sense. Now what is the rule, what is the explanation? Decimal expansion of each rational number is terminating. Look at it, all these decimal expansions are terminating, and in the prime factorization of the denominator, so the denominator is 2, the prime factorization of each every time. Look at it, 8 here, factors of 8 is 2 raised to 3, 5 here, prime factors of 5 is 5, 100 here, prime factors of 100 is 2 raised to 2 into 5 raised to 2, 500, prime factors of 500 is 2 raised to 2 into 5 raised to 3. So in the prime factorization of each of the denominator in each case, there are only two numbers, 2 and 5. यहाँ पे आपको सिर्फ 2 और 5 ही दिखेगा, इसके अलावा कुछ नहीं दिखेगा. 2 5 2 5 2 5. See, there can be power can be other than 2 or 5, but the base is 2 and 5. So only 2 digits, only 2 numbers, 2 and 5 is seen here. So the property Q must satisfy for the terminating decimal expansion. So अब Q के पास कौन सी प्रॉपर्टी होनी चाहिए कि जिसे हम terminating decimal expansion ही मिले? So Q must be in the form 2 raised to m 5 raised to n. Q है वो 2 raised to m 5 raised to n फॉर्म में होना चाहिए. मतलब जो डिनोमिनेटर है उसका प्राइम फैक्टराइजेशन निकालो तो उसके प्राइम फैक्टराइजेशन में हमें 2 ही नंबर दिखने चाहिए, या 2 या 5 या दोनों में से किसी एक या दोनों. उसके अलावा कोई प्राइम फैक्टर हमें दिखना नहीं चाहिए. वेयर m and n आर वॉल नंबर्स. सो m and n वॉल नंबर्स हो सकते हैं, वो पावर 0 भी हो सकती है तो 2 निकल जाएगा. अगर 5 रेस टू n n 0 है तो 5 निकल जाएगा, या 2 या 5 दोनों में से एक या दोनों यहाँ पे हो सकते हैं, तभी हमें टर्मिनेटिंग डेसिमल मिलेगा. इफ वी डोंट हैव इन द डिनोमिनेटर, वी डोंट फाइंड, if we find other than 2 and 5, we will be having non-terminating decimal expansion. So I think you have got this. Okay. Now my friends, next question, 7th one of exercise 1.3. Write 3 numbers whose decimal expansions are non-terminating and non-recurring. Very good. So this is the 3 examples. Non-terminating and non-recurring means what? There must not be a repeating block of digits. While you write the decimal, any number in the decimal form which is terminating and the block of any block of digits must not be repeated. So look at it, 1 and 0, but no 1 and 0 here. Okay, so you cannot see any block getting repeated. So this is irrational number. This is non-terminating and non-recurring decimal number, and that's why this is irrational number. Once again, look at it. 2 3, 2 times 3, 2 3 times 3, 2 4 times 3. Not a block of digits is getting repeated. So this one is non-terminating and non-recurring. You can also write this 1 3 5 7 4 2 9 6 3 5 8 4 2 9. So randomly you have to write the numbers, so, and be sure that any block of digits is not getting repeated. Okay, so these are the I can write by myself. You can write whatever you like, but you have to follow the rule that it must be a terminating and not a single digit or a block of digit is getting repeated. Okay, then it becomes non-terminating and non-recurring decimal expansion. Now question number 8. Find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay, these two numbers are given in the form P upon Q. These two numbers are rational numbers, but we have to write 3 irrational numbers lying between these two rational numbers. Since my friend, you know that irrational numbers can't be written in the form P upon Q. ऐसे फॉर्म में P upon Q फॉर्म में हम irrational numbers को नहीं लिख सकते. सो इरेशनल नंबर 3 हमें इस दोनों के बीच अगर का लिखना है तो पहले क्या करना होगा, ये दोनों नंबर का हमें डेसिमल फॉर्म फाइंड करना होगा. सिंस irrational numbers can't be written in the form decimal form, since irrational numbers can't be written in the form P upon Q, we have to find decimal expansion of given rational numbers 5 by and 7 and 9 by 11 so as to find the irrational numbers lying between them. ये दोनों का अगर हमारे पास डेसिमल फॉर्म होगा तभी हम इस दो डेसिमल फॉर्म के बीच लाई करने वाले इरेशनल नंबर्स को लिख पाएंगे. क्योंकि इरेशनल नंबर हमें लिखना है वो तो अपने दिमाग से ही निकालना होगा. हर स्टूडेंट अपना खुद का इरेशनल नंबर दिमाग में से निकालेंगे और हर एक स्टूडेंट का आंसर अलग भी हो सकता है, लेकिन हमें ये बाउंड्री को फॉलो करनी है कि इससे वो बड़ा नहीं होना चाहिए, इससे वो बड़ा नहीं होना चाहिए और इससे छोटा नहीं होना चाहिए और इससे ये बड़ा नहीं होना चाहिए. सो इस दोनों के बीच का ही सिर्फ होना चाहिए. ओके, सो टू राइट द इरेशनल नंबर्स लाइंग बिटवीन 5 by 7 and 9 by 11 we have to find the decimal form of 5 by 7 and 9 by 11. So I found out the decimal form of 5 by 7, which is 0.714285 up to infinite. Okay, we started with 5, we come up to 5 as a remainder. So this is the block which will repeat. ओके, ये ब्लॉक रिपीट होगा, सो हम रिपीट नहीं करेंगे. ओके, सो दिस इज अ रेशनल नंबर एंड इन द डेसिमल फॉर्म ऑफ द रेशनल नंबर यू विल गेट द रिपीटिंग ब्लॉक. ओके, सो दिस इज द वैल्यू ऑफ 5 by 7. डेसिमल फॉर्म ऑफ 5 by 7 is this, and decimal form of 9 by 11 is 0.81. So you will get 0.81, 81, 81, 81 again and again. So in the repeating block there will be 2 digits, 8 and 1. Now 0.714285, we have to find the 3 irrational numbers lying between 0.714285 and between 0.81. So I tried myself to write 3 irrational numbers lying between these two rational numbers. See, slightly bigger than this, 72, 722, 722, 7422. This number is bigger than this one and smaller than this one. Again the second number bigger than this one, smaller than this one. 781, 7811, 78111, 78 4 times 1. Okay, and the third number bigger than this, smaller than this, lying between these two numbers. 0.80, 880, 880, 4 times 80, and like this. So I think you are able to understand this question and understand some rules regarding repeating block. What is repeating block of digits in the division, what is non-repeating block, terminating and non-terminating decimal expansions, like this. Okay, now my friend, ninth question of exercise 1.3, classify the following numbers as rational or irrational. So a lot of discussion has been made about the rational numbers and irrational numbers. Now we have to classify. The first one is root 23. See, 23 is not a perfect square number. So root 23 is irrational. Okay, irrational numbers. So अगर कोई परफेक्ट स्क्वायर नंबर नहीं है तो उसका स्क्वायर रूट ऑलवेज इरेशनल ही होगा. नाउ रूट 225, माय फ्रेंड, यू नो दैट 225 इज अ परफेक्ट स्क्वायर नंबर. इट इज अ स्क्वायर ऑफ 15, isn't it? 225 is a square of 15. So square root of square of 15 will be 15. Since 15 is a natural number, since 15 is a natural number, and we know that all the natural numbers are rational number, and therefore root 25 is a rational number. Okay, rational number. Now 0.3796. See, this one is a terminating decimal expansion. Since given is a terminating decimal number, so it's a rational number. So given is a terminating, and any terminating decimal expansion is a rational number. Now here, look at it. Observe carefully. 7.478, 478, 478, 478. So you get the repeating block of digits. Here we get the repeating block of digits. So the given is a non-terminating and recurring decimal number. Okay, so we get that block of 3 digits repeating. So this one is though non-terminating but recurring. So therefore 7.478 is a rational number. नॉन टर्मिनेटिंग लेकिन रिकरिंग है तो वो रैशनल नंबर होगा. सी 1.10, 100, 100, 100, 1 times 0, we don't get any block repeating. So the given is a non-terminating and non-recurring decimal number. And therefore the given is an irrational number. Okay, so this one is an non-terminating and non-recurring. See, not terminating, here we get that it goes up to infinite, means non-terminating, and not a single digit or a group of digits are getting repeated. So no block of repeating digits here. So this one is a non-terminating and non-recurring decimal number, and that's why it's an irrational number. Okay, very good.